Okay, today we will learn about tree traversal and binary tree. So I guess last time everyone is clear with the concept of tree data structure. Yes, no, anything. Yes, ma'am. Okay. So okay, today we will see binary tree because there are lots of different tree, and today we will just see binary tree. But before binary tree, I just want to go from the tree traversal. Tree traversal is like visiting each of the node at least once. Means if you want to traverse from first node to the last node, that is your leaf node, and it will be called as tree traversal. So as we already know, tree is a non-linear data structure and it follows a hierarchical relationship among all the nodes. So if you want to go from one place to another, then those nodes are connected by age. So later we will also learn about graph. Graph is also similar to tree. Graph also has like multiple nodes and edges. So in tree traversal, there are three types: in order traversal, pre-order, and post-order. It's just like your stack. Remember, in stack we had in order, uh, infix, prefix, and postfix. Remember infix, prefix, postfix? Yes, notations. So just like stacks, we have, but you know the concept of infix, prefix, postfix, right? Whenever we write an expression, we use infix. The normal way we can learn. Okay, so similarly, means concept is somehow similar. So in case of tree also, there are different ways to travel the tree, right? Because in a tree we have lots of subtrees, and again subtrees have different nodes and all. So there are certain ways by which we can traverse through a tree. So those are three types: in order, pre-order, and post-order. So what is in order traversing? In order traversing means first you will traverse the left node, means left subtree, then you will read the root node, then you will go to the right part. Okay, suppose in this case this is a tree. So if it's a in order traversal from 5, how will it go? We will first read the left node. We will start from the left subtree. Okay, if there were more left subtrees, then we have to start from the left subtree. So in this case we have two subtrees, right? One, this is your root, this is your root, and there are two subtrees T1 and T2. Okay. Now in this case, in order, we always have to start from the left. Okay. Then we, someone is waiting in the lobby. Okay. In this case, just remember we have to follow left, root, and right. Okay. This is the main order we have to follow for in order. So in this case we have two subtrees T1 and T2. So again for this node we will again follow the left right thing. Okay. So here first left node is your 5, then we will go to 12. After that we will visit the right one. Ah, right one. Okay, so you can see here first we traverse 5, then it's 12, it's left, then root, then this is right again, then this subtree is done, then we will move to root again. So this is our root again, and then we move to the right side, right subtree, which is 9. Now 9 doesn't have any children. If it had children, that means we have to again start from the left, root and right. Okay, the main order here is the left, root, then right. Is it clear? Tular said yes. Yes. Okay, if clear, then tell me what will be the in order traversal here. This is 1, 3, and 5. Okay, tell me the in order traversing. যদি আৰু element থাকিলে you can follow here. দেখা নাপালো 4, 2, 3, 1, 4, 2, 5, 1, 3. Yes, Dular and Deepa, correct. So if it is in order, you will always start from the left. This is your left subtree and this is your right subtree. Correct? Again in the left subtree, you will again check the nodes for the left. Again for this particular node, this is your left, so it will 4. Then you will visit root, then 5. So this one is done, right? Left, root and right. So this portion is done now, correct? Now you will visit your root node, which is 1, and then you move to 3. Okay. Okay. Now if I'm telling you there are 3 more roots, 10 and 20. Now you tell me what will be the in order here. Now you tell me. This tree has 2 more nodes, 2 children. What will be the in order now? Oh, yes, correct. So for this one, this will remain same. Okay, now in the right subtree, we have again 2 nodes, that means 2 children. Then again we need to follow the same rule. Left node, which is 10, then 3, and then 20. Correct. So clear in order? Okay, Paris Asoba. 10, 3, 20. Yes, correct. If I say there's one more children, one more nodes here, maybe 30. Then আচ্ছা আৰু এটা 30 আছে কি হ'ব there's one more node I just added now 30 yes correct you just need to add the 30 in front okay so you will come here then come here because this one has a node this one has only one node and it will go on okay so in order is here so next is our pre-order traversal okay so what happens in pre we will first traverse the route yeah, for the pre-order we will first traverse the route then left and then we'll go to right okay so in this case what will be the answer here it is left sorry route left and right tell me the answer for this one any guesses say 12 5 6 1 9 correct so in this case, we will see the root first. So in this same case, we will always consider the left and right subtree. Okay. So when we come to left and right subtree, we will again see the root. So here first root will come, then our left one 5, then 6, then again we come here 1, and then we finally go to the last position. Try this one, the same one. 3, 4, and 5. What will be the pre-order? 1, uh, 2453. 2451. Wait, wait. You guys are correct. I'm the one who just gave you the wrong answer. Then, okay, if you go from the root, that means you have to see the root first. Okay, so 1 will come here. Then you will move to left portion. Okay, so in the left portion, again you will see the root part. So it will come to 2. Okay, then in this case, you have two children, one is left and one is right. So after reading 2, you will read 4 and you will read 5. Okay, then in this case, 1, 12, 6, 9, that would be the order for the example. Which one the example with? This 3 will come later. 1, 12 will be the order for earlier. Wait, let me see. Okay, in this case, you will first see the root. Root is 1. Then you will move to the left subtree. So in the left subtree, you will again read 12. Okay. Then in the left subtree, you have two children. So you will write 5, then 6. So this tree is done. Then you go to the right side. That means your right child. There is only one child. So it will be 9. Okay. So in order, you will go from the left side. Anything happens, you will first move to the left side. Then you again see whether that node has another subtree or not. So always come from the left one. But for the in order one, pre-order, we will see the root first. After reading the root, then you will decide whether there are left and right subtree or not. If there is a left subtree, again you will follow the same thing. Root, left and right. Okay. So in this case, if I just add 10 more, what will be the answer? Yeah, for this one, if 2, one, 2, 4, 10, 20. Okay. So in this case, same, this portion will remain same. First, we will go to 1. Okay. Then we will move to left. Okay. Here I am reading 2 again. Okay. Now left again. So here again this is 4. So this 4 will come. So for this one, left and right children is 10 and 20. Then we move up again. Okay, because here we have left out 5. Then we take 5. Then we move again. Last we take 3. Yes. is ruler is correct. Okay. So next is our post order. Third one is your post order. So in two cases we saw in order left, root, right. In pre-order it was root, left and right. Now in case of post order it will be just opposite. That means it will come from your left, then you go to right, and at last you go to the root. Okay, so let's take the same example. 1, 2, 3, 4, 5. So what will be the post order here? We will see the left first. Okay, so you directly come to the bottom part. Left is your 4, then right is your 5. Next for this the root is 2, then this left is done, so we will move to the right, which is 3, and last we read the root, which is 1. 4, 2, 5, 2, 3, 1. Yes. Now if I say there's two more, one more, then now for this case everything will remain same, means this portion will remain same. Okay, yeah, Lexi. Then for this right subtree we will again move from the left, right and root. So once you reach here after it, sorry, one will come later. Okay, the 3 portion. So here again you will move to like 20, then 10, then you read the root here, and in the end the final root will be here. Yes, correct. Okay, so this is your tree traversal. So just giving you summary, we have in order moves, left, root, right. Then we have reorder, which is your root, left and right. And then we have post order, which goes opposite, is left, right and root. Is this tree traversal clear to everyone? For the in order, for this one, what will be the answer? First, we will see the left. So this tree has one is left. So again for this left, we will go to the left again. So 4 will come. Then we will read the root 2. Then we will go to the right. Correct? So then we move to the root again for this subtree. Then we move to right. Okay, now our this right subtree has again two children. So we will read this 21st. Then we move to the root 3 and then we read 10. Okay, if you want to do the pre, what is this? It's root left and right. So for pre, this is our root. So we will read the root first. Okay. After reading the root, we will check the left subtree. In this left subtree, again we will read the root first. Okay. Now we will read the left and right children. Correct. So again for this one, we will move to here. Okay. 3. So after reading 3, we will again see the left one, then right one. Then we have post. For the post, what we do, left, right and root. So for this node, we have left this one. Again for this node, we have left this one. So first we will read 4, then we will read 5, then we will go to the root, which is 2. Okay, so this left portion is done. So now we move to the right portion, correct? So in the right portion, again we have two children. So in this case also we first go to the left child, then go to right child, then we move to the root, then we finally read the root. So this portion clear, right? Free traversal, everyone. Yes, no. Okay, good. So this is your basic tree traversal for any type of trees. Okay, so in order, pre-order, post-order, just remember the way it moves. Okay, just need to remember that. So next we, okay, post-order done. Okay, next is our binary tree. So what is binary tree? See, in the previous trees, we saw that the root can have 2 or 3 or 4, 5, any number of subtrees. But for the binary trees, it has a restriction. Okay, the restriction is that each node can have at most two children. थोड़ा confusion हो रहा है post and pre में. पोस्ट एंड प्री में, ओके, पोस्ट प्री में क्या होता है, पहले रूट लोगे उसके बाद लेफ्ट एंड राइट, एंड पोस्ट में क्या होता है, पहले लेफ्ट एंड राइट देखोगे और उसके बाद रूट आएगा. प्री में क्या होता है, फर्स्ट वी रीड द रूट राइट, देन लेफ्ट एंड राइट. In this case, this is the root, so we read the root first, then we move to the left subtree. So in this left subtree, we read the root first, so 2 is here, right? So after reading the root, again we will see the left and right. Now left is here is 4 and right is 5. Okay, that means we are done with this left subtree. There are no more children and these are the leaf nodes. So this left portion is done, our root is done, left subtree done, then we move to the right subtree, right? So in the right subtree again we will follow the same method. First we will read the root, and then we will read the left child which is 20, and then it will read the right portion which is 10. Okay. Now in case of post, what happens is the opposite, left, right and root. So in this big tree, this is your root, correct? That means we will read this one in the end. There are two subtree, this two and this one. Okay. Again in this tree, we will follow the same thing, left, right and root. So in this case, again the left is 4, then right child is 5. Then after that we will read the root. Okay. So in this case this left portion is done for this. Okay. Then we will move to the right. Right is this subtree. Again in this subtree for tree node 3 there are two children 20 and 10. We will follow the same thing again. So we will first read 20, then right which is 10, then we will finally read the 3. Now at this point we have read both left and right. Now the root is remaining. So in the end we will read the root. Is it clear? ये समझ में आया? Okay. So binary tree, what is binary tree? In normal general tree, it can have 1, 2, 3, 4, 5, any number of children. But in case of binary tree, there's a restriction that each node can have at most 2 children or less than that. Means one node can have either 0, uh, 1 or 2. Okay. 0 means 0, the leaf nodes are 0 because they never had any children. Then it can have 1 or 2. So your binary tree normally partition into 3 disjoint subtrees. This is just normal one. Root of the node, then left subtree, which is also a binary tree, then your right binary subtree. That means what? In case of binary tree, each of the node will follow the same thing. Every node will have two children. So even the left subtree and the right subtree will also be another binary tree. Sounds like बच्चे मीठी खीर ज्यादा. तो बाइनरी मतलब टू है, बाइनरी नहीं है. Nice joke. So binary means two. Two means each node can have maximum two nodes. Again, there are different types of binary tree. Okay, binary tree can be your full binary tree, perfect binary tree, complete binary tree, and so on. So let's just see what is full binary tree. Okay, so for the full binary tree, what is that? It's just your binary tree, and every parent node or even the internal node has either two or no children. So this is your normal binary tree, your root node, and the internal nodes can have either two or no. एक भी नहीं हो सकता. Okay. So in this case, how will you find the number of leaf nodes and what will be the number of nodes? See, if the number of nodes are n, then a full binary tree is at least n equal to twice h minus 1. That means that's the height, okay? H means height here. And the maximum height can be twice h plus 1 minus 1, okay? And the number of leaf nodes will be the L plus 1, okay? L will be L of internal nodes plus 1. Okay, so your total number of leaf nodes will be the internal nodes plus 1. So, any guesses? समझ में आया कुछ? What is the height? How we find out the height of a tree? Okay, what's the height of this tree? What is the height of this tree? Height means you need to count the number of edges, the longest edge. What's the height of this tree? Okay, this meeting is going to end soon. The height is 3 here. Height is 3. You just need to see the longest edge. What is the longest edge? From root to the leaf. There are 1, 2, 3. So height of this tree is 3. That means maximum number of nodes what? 3 into h. 6 plus 1, 7. Okay. And minus 1. Why it's minus 1? Again 6. That is the maximum number of nodes you can have. Then there are lots of other binary trees. I'll just continue in the next class. Okay. Okay, next class we will. I'll show you. Actually, I'll show you how to find out the height, because for each of these different trees, there are certain formulas by which you can find the height, the number of nodes. And in competitive exam, most of the time they just ask about this question, like how many nodes will be there, what will be the height of a tree and all. Okay, so I'll give you the examples how we can find out. Example is here, just that you need to understand. Okay, I'm stop sharing. It's going to end. Just take attendance. Okay, I've taken your attendance, so I'm ending the meeting here. Okay, thank you.